Good morning, young people. This is Mrs. Rains. Today we're going to be talking about atomic structure and what makes up an atom and how we talk about that. So the first thing that we need to talk about are subatomic particles because we know atoms divide up into particles. We know that they divide up into the electron, the proton, and the neutron. Electrons have a charge of -1, protons have a charge of +1, and neutrons are neutral or zero charge. The mass, this is a little bit strange, and I know it says 0 AMU right here. It says 0 AMU, but we have to be really careful about that because as you can see right here, in grams, electrons do have a mass. They do have a mass, but if you look at 9.11 times 10 to the -28th as compared to 1.67 times 10 to the -24th, that is like 2,000 times smaller than the mass of a proton. So I would need around 2,000 electrons to equal the mass of one proton. The largest element that I have on the periodic table has 118 protons, 118 electrons. And that is not even a tenth of what I would need to have the number of electrons to get equal to the mass of a proton. So we essentially say that electrons have negligible or no mass because of that. That doesn't mean that they don't have any mass. That just means it's so small that it can't be added up in a big enough or great enough amount. The other thing that's really important about knowing where these particles are is knowing where they are found. Electrons are found in the electron cloud outside the nucleus. Protons and neutrons are found inside the nucleus. In the next couple weeks, we're going to be looking at the nucleus, and then after that, we're going to be exclusively looking at the electron cloud. So we're more, as chemists, concerned about the electron cloud, but we do have to understand the nucleus a little bit to be able to describe some things that we're going to be doing. So here we go. Atoms are composed of identical protons, neutrons, and electrons. So if they're identical, how do we tell one atom of one element from another atom of another element? How do we do that? Well, every element is different because they contain different numbers of protons. So protons are the particle that defines the atom. So if I know the number of protons, I know what the atom is. Well, how do I do that, Ms. Rains? How do I do it? So it has to do with the atomic number, because the atomic number, also known in chemistry with the big letter Z, of an element is always equal to the number of protons found in the nucleus. So the atomic number on the periodic table, the atomic number for oxygen is 8, so that means oxygen has 8 protons. The atomic number for aluminum is 13, so that means it has 13 protons. The atomic number for lead is 82. That means lead has 82 protons. I can predict what the thing is because I know the atomic number or I know the number of protons. And because they're the same, they will always be that way. Now, this next statement, some of you are going to say, but isn't that the same thing? Let me explain. The next statement says the number of protons in an atom are equal to the number of electrons. Atoms inherently are neutral. That means that the positive and negative is equal to one another. So yes, protons and electrons are equal, but we have other things that are not atoms that don't have equal numbers of protons and electrons. But the proton is what always defines an atom as a particular kind of atom. So I want you to remember atomic number equals protons. In an atom, protons equal electrons. There's a reason. I don't want to scramble your brains when we go to the next thing in the next unit, okay? Atomic number. The atomic number of an element is the number of protons. We've said that multiple times now. So if I have this table and I know the atomic number of carbon is 6, I know the number of protons of carbon is 6. Phosphorus atomic number? Yeah, it's 15. So the number of protons is 15. Gold? Well, gold's atomic number? Yeah, Au 79. So the number of protons is 79. Very good. Now we come to a different number. So atomic number is on the periodic table. This number that we're getting ready to talk about is not on the periodic table. The mass number is not on the periodic table. The mass number instead is on, it's not anywhere on the periodic table. There's something called an atomic mass on the periodic table. Mass number and atomic mass are not the same things. We're going to be talking a lot about that a little bit later. But mass number is equal to protons plus neutrons. So the number of protons plus the number of neutrons will give me my mass number. Remember, back to the first slide, protons and neutrons have essentially the same mass. So protons and neutrons are equal, 1 and 1. So if I have 1 proton and 1 neutron, I have a mass of 2, mass number of 2. So let's look at a table. So the nuclide is describing the atom. When I say a nuclide, I'm talking about the atom. So I have oxygen over here. I see the word oxygen. Well, I can look that up. Periodic table, oxygen, O is its symbol. So that means that there are 8 protons. Because there are 8 protons, there are 8 electrons. The mass number, well, that's 8 plus 10, which is 18. So what do we call this nuclide? We call it oxygen 18. That's one way to name this atom, oxygen 18. So if we look at the rest of this, we see 33 is the number of protons. Well, protons equals the atomic number. So what's atomic number 33? Yeah, exactly. Okay, so that's arsenic. Okay, AS is arsenic. So we know that that's arsenic because it's got protons of 33. So how many electrons? It has 33. Mass number, what do? We add protons plus neutrons. So 33 plus 42, that gives us 75. So this nuclide or this atom is called arsenic 75. If we look here, we see 15, but we see this number right here. We see 31. Look at where the 31 is in terms of where the 18 and the 75 are. The 31 must mean it's the mass number. So we know the mass number is 31. Now what do we know? We have 15 protons. Well, what is atomic number 15? P, yeah, phosphorus. Very good. So we know we have phosphorus 31 is our nuclide. Now let's figure out the rest. How many electrons do we have? We have 15 because they're the same as the number of protons in an atom. How do I figure up the neutrons? Well, I have the mass number and I have the number of protons. So if I rearrange this equation a little bit, the number of neutrons is equal to the mass number minus the protons. So 31 minus 15 gives me 16. Very good. So complete symbol. This is another way of writing the nuclide. So we just saw in this last thing that we can write the nuclide by saying its name and its mass number. So that's one way of saying an atom. Another way of saying an atom is to use the complete symbol. The complete symbol contains the symbol of the element, the mass number, and the atomic number. So the symbol here is symbolized by X. Why X? Because there is no element X. There's an XE. But there is no element X. X is just a generic symbol for the symbol of the element. Then we have on the bottom the atomic number. That's the subscript number. And on the top, as a superscripted number, the mass number. So this is what the complete symbol looks like. It gives us the mass number, the atomic number, and the chemical symbol. Everybody good? So let's try some things. Find each of these. The number of protons, the number of neutrons, the number of electrons, the atomic number, and the mass number. So what are we given? We're given this symbol. So what do we know? Well, we know that this bottom number is the atomic number. So that means the number of protons is, sorry, I must have to write. All right, let me see if I can get my pen up. Sorry about that, guys. All right, so this is the atomic number, so that means the number of protons is 35. Okay, the number of neutrons, well, how do I figure that out? I take the mass number minus 35, and that will give me, let's see, 7, 10, 5, 45. So I get 45 neutrons. How many electrons? Well, it's an atom, so the electrons are the same as the number of protons, so that's 35. What's the atomic number? Oh, it's 35. It's already in the symbol. What's the mass number? 80, because it's in the symbol. Pretty simple, right? Okay, let's try another one. Okay, if an element has an atomic number of 34 and a mass number of 78, what is the number of protons? So if the atomic number is 34, then the number of protons is, yeah, that's right, 34. The number of neutrons, well, I have to do a little math, right? Because I have 78 as my mass number. I have 34 protons, so I subtract that. 8 minus 4 is 4, so 44. So I have 44 neutrons. Now these two numbers should add up to be 78. Number of electrons, well, they're always the same as the protons because it's an atom, so 44, sorry. So that's 34 electrons. What is the complete symbol? So this is where we have to look a little bit. We have to look at our periodic table, and we have to look at some other stuff. So we know that 78 is going to go as a superscript, 34 is going to go as a subscript. What's the chemical symbol? Atomic number 34 is selenium, or Se. Very good. Okay. So if an element has 91 protons and 140 neutrons, what is the atomic number? So what is the atomic number? Well, 91 protons means the atomic number is 91. What's the mass number? Well, I've got neutrons and protons, so I have to add them together. So 140 plus 91, right? That's 1, 4 and 9 is 13, carry the 1. I have 231 is the mass number. How many electrons does it have? It has 91. What is the complete symbol? Well, pretty simple, right? The mass number goes on top, atomic number goes on the bottom, and then we look it up on the periodic table. This is proactinium, or protactinium, Pa. Okay? So an element has 78 electrons and 117 neutrons. What is the atomic number? Okay, well, let's go down to the number of protons first. What do I know? The number of protons is equal to the number of electrons, so I have 78 protons. So what is the atomic number? Ah, yeah, 78. And this is the case where you're like, well, that's the same as number of electrons, Ms. Rains. Yes, it is. However, remember, I'm just trying to get you to understand that the atomic number is equal to protons, and protons are equal to electrons. I do understand that they're equal to one another. I get that. So to get the mass number, I have to take 117 plus the number of protons, which is 78. 7 and 8 is 15. Carry the 1, that's 9. So I have 195. So I have 195 as my mass number. What's the complete symbol? Well, the mass goes on top, the mass number goes on the top, atomic number goes on the bottom, and the symbol for this is Pt, platinum. Okay, we're going to end right there. Hopefully you've gotten some information that's going to help you for tomorrow. Thank you very much.